Welcome back. Sheet metal is fun. Today's a big day. We're going to learn how to read a tape measure. Come on inside. Sheet metal can fly. Sheet metal is fast. And last but definitely not least, sheet metal is fun. Look at that spark plug butterfly. Come on, that's a keeper. All right, today's little big lesson, we're going to learn how to read a tape measure. But before we get into the tape measure, I want to go back over the pan that we made last time, and we're going to put some photographs in here of some of the projects that we've recently done where a pan was a major component. Here are those pictures. I'll see you right back here in a minute. Hey, some of that stuff's pretty cool. Some of that is actually at our house. The toilet cover. All right, we've put this off long enough. We're going to learn how to read a tape measure. But in order to really understand the tape measure, I want to go back over fractions. We're going to make a very simplistic trip through Fraction Town. Here we go. Fractions are parts of a whole. Here's a whole. Let's call this a pie. The denominator tells you how many parts are in the pie. The numerator tells you how many parts you have. So here we have 2 parts of a pie, but we only have 1 part. We don't have this part. So what I want you to do in order to understand the tape measure, I want to go through fractions, and we're going to talk about the numerator and the denominator. I didn't come up with this method, and honestly, I don't even remember where I did learn it, but I want you to be able to do fractions in your head without a big chalkboard. So let's say we have a half inch. If we wanted to know what's half of a half inch, all we do is double the denominator. A half of a half inch is 1/4 inch. What's half of a quarter? We leave the numerator alone, we're going to double the denominator. An eighth is half of a quarter. What's half of an eighth? This is getting pretty sketchy, pretty involved. All we're doing is multiplying the denominator times 2. Double that denominator and you get half. Here's a 16th. What's half of a 16th? All right, I hear you out there. That's right, 1/32. That's all there is to it, to getting half of a fraction. But now here's where it gets a little more involved. Let's say we had a number, let's say we wanted to know what half of 51 3/4. We want to know what half of that is. First of all, we're going to go to the next even number down. So we're going to go to 50. What's half of 50? 25. That's right. Add the numerator to the denominator. What do we have? 7. Double the denominator. 8. 4 times 2 is 8. 25 and 7/8 is half of 51 3/4. I wanted to show you on an odd number. Now, using the lesson that we've already learned, if I told you 50 and a half, now that you know the system, you can do this number in your head. What's half of 50 and a half? 25 1/4. Piece of cake. So we don't have to be afraid of fractions. We don't have to get a calculator. Plus, it's good to do this work in your head. It's a good exercise. One of the things that I want you to learn and to begin to process in your mind is I want you to begin to adopt mechanical thinking. I want you to begin to come up with solutions. I want you to begin to process on your own. Put the calculator down once in a while. Get out a pencil and paper and do some math with a pencil and paper. It'll make your head work, and that will pay you big dividends in the end. So now that we've learned fractions, let's do a couple more. So whenever you use this rule, if you forget, one of the things I always do, let's say it's been a month since you've done any fractions, always go back to an easy one. Let's go back to a half. Go back to an easy one. What's half of a half? 1/4. And let's go back to, let's do the odd number. Let's go back to 7 3/4. The next even number down from 7 is 6. What's half of 6? 3. 3 plus 4, 7. 4 times 2 is 8. I think we already did 3/4. Let's try one that's not 3/4. It's a great system, and I want it to be second nature. I want you to be able to just do fractions in your head, and it will move you forward in life. You'll be happy with the result of using your brain instead of a calculator. And don't be intimidated. It works on every fraction. Let's say we had 11 7/8. Before today's lesson, if somebody came up to you on the street and said, "Hey, real quick, what's half of 11 7/8?" It's going to be a blank stare on a lot of us. But let's do this real quick. We're going to take this down to the next even number. That would be 10. Half of that is 5. Add 7 and 8 together. 8 times 2. Look at that. Half of 11 7/8 is 5 15/16. And you did it in your head. You didn't even think you could do it, and you just did it. I want you to do a bunch of these. Do 50 of them. Do 100. Impress yourself. Work your brain a little bit. All right. So now that we understand fractions a little better, they're not as intimidating. Once something is not intimidating, it's a lot easier to use it for our own purposes and to use it as a tool. So now let's look at a tape measure. Let's draw a 1 inch. Let's make it nice and big. This is the end of the tape measure. Let's call that 1 inch. That's the biggest 1 inch in history. But now that we've gone through and we've learned how to divide fractions in half, let's fill in some of the numbers. Halfway between here, right here. What's half of 1 inch? Actually, 1 inch in the fractional form is 1 over 1. You have 1 pie and you have 1 piece. You have the whole pie. So once we look at 1 in its fractional form, 1 over 1, what's half of 1? Here we go. Half. All we did was multiply this times 2. So we're going to go to this inch diagram that we have. We have 1 inch here. We just cut that in half. Half inch. Now, let's go to the middle of that. We're going to have 2 of those. All right. What's half of a half? That's right. 1/4. Same thing over here. You see where we're going with this. Let's make another line right here. We're going to have 4 of these. What's half of a quarter? I didn't have to wait. I already heard you. 1/8. Now, all I've done is taken this inch and divided it into eighths. We could go to 16ths, and you can if you want. It's right here. We're just going to fill these in. I'm not even going to mark them. Everybody knows that's a 16th. So let's look at this inch. Our first mark is a 16th. Our next one is an 1/8. Then this one, 3/16. 4/16. We break that down. It's a quarter. 4/16 is a quarter. So if we look at this inch and we're going to cut it in half, that's the half. We cut the half in half, that's a quarter. Cut the quarter in half, that's an 1/8. So we have 1/8. We have 1/4. We have 3/8. We have a half. We have 5/8. 3/4. 7/8. 1 inch. So if we're looking at our graph of 1 inch and we've divided this into eighths, basically we have a pie and we've made 8 slices in that pie. Each one of these spaces represents a slice in that pie. You could do pizza too. Pizza works just as well as pie. So here's an 1/8, an 1/8, an 1/8, all the way across. We've divided this inch into 8/8. Oddly enough, that's the same. Not 1/8. Oddly enough, 8/8, same as 1/1. So one of the things I want you to notice, I'm gonna grab a tape measure, don't go anywhere. One of the things you're going to notice on a tape measure is the end wiggles around. The end wiggles around the thickness of the hook on the end, because there are 2 dimensions on this piece of square tube. there's the outside dimension and there's the inside dimension. So if we're going to hook this on the outside, that's 4 inches. And if we put it to the inside, that's 3 5/8. I want to write that down, 3 5/8. So you see, the tape measure had to have this small amount of movement in the end to go from hooking and giving us a true number and to reading on the inside. If the end of this was fixed, we would only get one correct dimension and the other would be off by the thickness of the hook. So that's the reason they're wiggly. Outside, inside. So the outside of this is 4, the inside is 3 5/8. I want to use that. I want to look at that. We had the outside, we're going to call that the OD. It's 4 inch. And the universal symbol for square. That is a 4 inch square OD tube. On the inside, it was 3 5/8. ID. So now that we've learned about fractions, if it's 4 inches on the outside and it's 3 5/8 on the inside, with what we know about fractions, we can determine the wall thickness on the tubing. Let's look at the difference. The difference between 4 inch on the OD, 3 5/8 on the ID, the difference is 3/8. That's the difference between the outside and the inside. 3/8 divided by 2. We're going to move the numerator over. Half of 3/8. 3/16. So this tubing has a 3/16 wall thickness on it. And we got that. No, we didn't even actually measure the wall thickness. We were able to come up with that information by measuring the outside dimension and the inside dimension and taking the difference between these two numbers, 3/8 in this instance, divide that number by 2 because we have 2 wall thicknesses on the tube, and now we know we have a 3/16 wall thickness in our square tube. 3/16 wall. All right, so now we know how to divide fractions. We know how to determine the wall thickness of square tube by measuring the outside dimension, the inside dimension, take the difference between the two, divide that in 2 because there's 2 wall thicknesses, and that will tell us how thick the wall is on our square tube. One of the things that anytime we take on a teaching endeavor like this, some of you folks are going to be way far ahead, and a lot of this stuff we're covering is irrelevant, or you learned it so long ago that this is redundant to you. But what I want to do at the end of all of our lessons, I don't want to leave any stragglers. I don't want to leave anybody behind. So that's why we're going to start at the ground level. That's why we're learning how to read a tape measure. Probably 98% of you folks that are watching this video, you already know how to read a tape measure. But there's some out there that maybe today in our diagram and some of the explanations that we've given, maybe that taught somebody, or that opened a door, or that gave somebody a better understanding. So what I want to accomplish with our series is I want to get from the people that don't know very much about mechanical thinking and innovative solutions. I want to bring everybody along. Now, some of you are already all the way down here. Some of you are back here. That's awesome. Maybe you do something for a living that doesn't require any mechanical thinking. But what I want to encourage you to do is to challenge yourself. Process the things that you come up against every day. See if you can process them mechanically. Take it apart. Why does it work? Why did we do what we did? One thing that I'm not going to do in all of our series, I will not tell you how to do something without telling you why we do it. I want you to know why we do it, because now it takes it from the chalkboard into your brain and into your understanding. And once you begin to think mechanically, it opens up a whole different world for you. Even if this is just a hobby for you, how to learn how to work with sheet metal, how to think mechanically. If it's a hobby, that's a great hobby. I make a living at it, and I've made a living at it for over 40 years. And it's been, well, I wouldn't say sheet metal is fun if it wasn't fun. I'll see you guys next time. Thanks for stopping by.